Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
So let's talk about Kubernetes, right? So we will talk about what is Kubernetes and why it is used, right? And then we will see the details about Kubernetes. So we will see how it is, what is the architecture. That's where we will spend most of the time. Then we will install Kubernetes. It's not actually much of an installation. It's a bootstrapping of various components. So we will bootstrap our cluster, and then we are going to understand some workloads. How do we create various workloads on Kubernetes? After that, we are going to talk about, in the workloads, we will talk about, for example, pods, then deployments and services. And I will also give a brief overview, right? Overview about many other workloads that you can deploy on Kubernetes, but we are not going to use them or talk or have a demonstration or detailed explanation on them, because in 4 hours we will do whatever we can do, right? So for example, I'll just say other workloads. We will also talk about a package manager for Kubernetes called HELM, right? So what is HELM? Why do we use it? How does it work? We are going to talk about that. And yeah, that's it. But a prerequisite, a strong prerequisite for understanding all this is that you know how containers work, right? How containers or Docker works. So, question to you: are you guys pretty comfortable with Docker and containers? You guys have already gone through that training, I guess. So should be okay in my opinion. But I want a yes or no from you. Great. Okay. So now that you know Docker and how it works, well, I mean, and did you also learn about Swarm, Docker Swarm? Okay. So let's say we have a machine where Docker runtime is installed, right? Docker container runtime. It's also called as Docker daemon, and it is responsible to run our containers, right? So Docker containers are installed, and on this machine we can run our containers, right? Let's say, for example, we have an application called Nginx, right? We have an application called Nginx. It has a Docker image. Now, how do we run this application? We say Docker run and image name, right? So it's when we say Docker run, we are only talking about Docker right now. It creates a container, right, based out of this image. So Docker run creates a container. You publish the ports, for example, port 80 on some random port here, and then your end users, can access your application on this port, right? This sounds familiar. Is this workflow understood? All right. Okay. So this is how it works, right? Now, this is okay to run an application, but to ensure that the application is running all the time and the application is available all the time for your end users, well, this is not enough, right? It's like running an application on a server. It's same like that. Instead of installing the application manually, you are just running it in a container, right? How do you ensure that the application is highly available, right? For example, what happens if this container crashes or this container is gone? What will happen then? There will not be any application available to the end users. Yeah. Even if the container is available, let's say one day you rolled out a new feature to your application and updated the container with the new feature, and the new feature got so popular that you have 10 folds of users accessing your application, right? There are, instead of 2 users, you had maybe 10 users or 1,000 or 100,000 users hitting your URL. In that case, you would like to scale things up, right? You want to add more backends to your application or servers to your application. Now you may want to add some.
Hey viewers, our Mastery in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So, what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
More pods, more containers, which can help in sharing the load. Well, with Docker, it's very difficult, right? So you don't even have the scalability with using plain vanilla Docker. Also, right, a worst case scenario, imagine this whole node crashes or whole system crashes, then everything is gone, right? You have to set up another machine, install Docker, run your containers, run the commands, and then see how it goes, right? So with plain vanilla Docker, we do not have, we have containerization, which is very good, but we do not have high availability, right? We do not have scalability, right? Also, we do not have auto scalability. That also is missing, right? One more problem with this setup is, well, to run the containers, the admins or the developers would require admin access on the terminal here for this machine. They will anyone who will start a container here will be a system user, right? So they need system user permissions to deploy their applications. Now you cannot give those permissions to your developers. There could be hundreds of developers developing applications and deploying them, and single admin team just to deploy containers also does not make sense, right? So how do you manage this? How do you enable the developers to deploy their applications but not deal with these system level access? How do you do that, right? So it's not a developer platform, right? Although the developers will have admin permissions on their laptops or their local team machines, but the deployment will happen on a production machine, right? On a central infrastructure where it's difficult to get admin access for everyone, right? So how do we deal with that? How do we ensure that the developers can deploy without worrying about their access to the physical infrastructure? So all these problems are solved by a category of tool known as container orchestrator. Okay, container orchestrator is an abstraction on top of your container runtime. Okay, and it takes care of ensuring that your containers are running at a desired state, they are scalable, and it allows developers to directly deploy containers by not even dealing with Docker directly. Okay, they don't need to even know Docker commands. That's what container orchestrator does. All right, now let's see how it does it. I'll get rid of this image because this is of no use now. So what happens is how a generic container orchestrator works, right? Not Kubernetes, a generic container orchestrator. So how it works is, let me take a maybe white pen itself. We have a set of Docker machines, right? So let's call it as node 1, node 2, node 3. And on all the machines, Docker is installed. Right? On all the machines, Docker is installed. And we use this cluster to deploy our containerized applications. Okay. From now onwards, I will also use a term called workloads, which is nothing but container, or in Kubernetes, they may also be pods. Workloads means an application which is running on a cluster. Okay. So there is a cluster of machines, node 1, node 2, node 3, and all are capable of running Docker containers, right? And along with these machines, we will also have another machine which will be part of the cluster itself. It will be called as node 4, for example. It also has Docker installed, but we will give this machine an extra capability of managing this cluster. Okay, so this will be a master machine. This is master, and others are just nodes, right? So worker node 1, worker node 2, worker node 3. So what will happen is that master knows how to talk to these machines, right? And how to distribute work to these machines. Okay, so if a container has to be run and master comes to know about it, and we will see how does it come to know about it. If master knows that, okay, I have to run 5 containers, it will instruct these nodes to run the containers. It will say maybe here run 2 containers on node 1, here run 1 container, here run 2 containers, right? So master will know what to do, and it will get work done by using these worker nodes.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Okay, so and this instruction to master that you have to deploy 5 containers, for example, is given to it by the developers. It is given to it by the developers. Developers need not know how to run container, where to run them, where is the infrastructure, how to log into those machines. Not required. Developers will say, just run my application and my application is consisting of the image called some image, Docker image, and it runs on some port, right? And it uses this volume, and that's all, and run 5 copies of it. And this master machine will receive this instruction, this state, application state definition, and then just ensures that this state is achieved by running corresponding application and number of copies over the cluster. Okay, now so how does this setup solve all these problems? For example, let's say this container crashes, right? Then the master node will immediately come to know that I was asked to run 5 copies. I was asked to run 5 copies of application, but there are only 4 running at this point. Let me fire up a new pod. So it will ensure that your application is always available, right? Now, let's say your developers say that, I started with 5 copies. Now move it up to 10 copies, right? I don't want 5 copies anymore. I want 10 copies of my application, or 10 replicas of my application. Then the master will receive this and will say, okay, I am requested to run 10 instances of this application. Right now 5 are running. Let me start 5 more. Here you go. Now 10 instances of these applications are running. Okay, so we discussed about high availability, that a container dies and it is then recreated. So the cluster ensures the availability of all the workloads, desired workloads. We also talked about scalability, that developers can say scale up my application, or it could be other way around. It can say I just want 2 copies, right? If developer has to pay for the resources from its pocket, then can based on the requirement it can say, okay, reduce the scale as well when not much traffic is there, right? So manual scaling, you can also configure master to scale up automatically based on the CPU utilization on the containers. If the containers are using 50% of their allowed CPU utilization, create one more container, right? Auto scale up. So auto scaling is also possible. Also, for high availability, we did not talk about other scenario. For example, this node goes down, node 3 crashes. Now master will immediately realize that, okay, there are 3 pods or 3 workloads missing, 3 containers missing, and I see one node is down, so let me rerun these nodes or these containers on the remaining machine on my cluster. So it will reschedule these containers on the cluster, right? So even though a complete machine was down, still there was place to continue running the application. Yeah. And finally, the development platform. So developers need not to know how to run the containers. They just need to know how to ask the cluster to run the application. That's all, right? No need to know Docker internals, how to run Docker commands, where Docker is installed, and things like that. Nothing required. Okay. So this is how the high level container orchestrator works. Now there are many examples for this. There is Docker Swarm, right? There is Kubernetes, and then there is Apache Mesos. These are all container orchestrator. Now on cloud also they had their own implementations, for example, AWS Elastic Container Service was one of the homegrown container orchestrator system, right? But now Kubernetes is the most popular container orchestrator platform, and it is completely open source, completely free to use. There are other enterprise distributions of Kubernetes. So, for example, you have um, OpenShift, then you have Mirantis, and then you have the cloud providers, right? Like AWS Elastic Kubernetes Service, and then all the cloud providers have this now. So you have GCP, Google Cloud Kubernetes Engine. So all these are commercially available distributions of Kubernetes, right? So they add their own features on top of Kubernetes. They provide some sort of support, some sort of guarantee on the application, and then they give it to you, and you pay for it.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Okay, and many times it is worth to paying for it. In my current organization, we use OpenShift, and we generally rely on the support provided by Red Hat, which is the vendor for OpenShift, and they maintain the cluster for us, and they help us in managing the cluster, so we don't have to hire our own team, right? So this is how the container orchestrator works, right? Any questions? Okay, so now let's talk about Kubernetes specifically, right? Let's highlight that this page was for container orchestrator. This is our topic of discussion here. Now let's talk about Kubernetes specifically. How does Kubernetes work? Now again, Kubernetes is a container orchestrator system, right? So we have a cluster of machines. We have, I'll just be here only. We have a master and we have various worker machines, right? Okay, so we have worker 1, worker 2, worker 3. Now, master is the main machine in the cluster, which ensures that the cluster or the workloads in the cluster are running in a desired state. Okay, so what happens is, from the developer's point of view, what happens is the developer will write a application state. Developer will say that I want my application to be deployed, and the application is based on Nginx, and it runs on port 80, and give me 5 replicas, for example, and I want to run this application, right? The developer just needs to give this. Now, where this Nginx is stored, how to pull it, how will the port be exposed, and all that is taken care of by the cluster. Okay, so this request goes to master. Now master will receive this request and it will realize, okay, there are 5 copies of this application configuration required, and it will instruct the worker nodes to run those copies, right? In Kubernetes, well, the minimum or the smallest manageable deployment object or deployable resource is called a pod. Okay, so what Kubernetes does is it runs 5 pods. Let me choose a different color here. It runs 5 pods of those application configuration, whatever is provided by the user. Okay, now what is a pod? Well, pod is nothing but a capsule kind of thing, a virtual capsule inside which you run your containers. So the Nginx based container will be encapsulated inside a pod. Okay, so container has some properties, right? Container has name and IP address, and then a port and things like that. Now pod can have more properties than container, right? So how pod can have labels, pod can have annotations, pod can have toleration stains, other properties also, which make it more manageable in Kubernetes, rather than just limiting itself to the properties of a container, which is defined by Docker, right? So what Kubernetes says, okay, I will not manage containers myself, I will manage pods, right? Inside the pods, I will put containers and I will ensure the containers are running there. But if I have to scale up, I'll scale up the pods. If I have to scale down, I'll scale down the pods. If I have to delete the application, I'll delete the pods. And the containers inside the pod will also get deleted, obviously, but pod is the smallest manageable resource in Kubernetes, right? There can be more than one containers inside a pod. All right. It is not a general use case, but it is possible. And many times we do it, right? And this is done only when one of the pod is dependent on another pod, or one of the pod is serving some special task for this particular pod. Okay, we will come back to this multiple containers inside a pod later, but for now, for the simplicity of the discussion, we will just understand that pods are capsules or encapsulation around a container. Okay, and this gives a capability of to Kubernetes to manage the workloads in much more efficient way. Okay, so when you give this desire that I want to run this application and 5 replicas, well, master machine will understand this and it will say, okay, run 5 pods, and in the 5 pods run these containers, right? So in the 5 pods the containers will run. Okay, so this is how it happens. Now how does master do it? How does master do it? This is the most interesting and the place where I will need complete attention from you. What are the various components in master that enable this orchestration? So let's talk about those. This is our master, right? This is our master, and let's say we have 2 more nodes, worker machines, right? Master. This is also known as control plane. Okay, now when the developer gives an input that deploy my application, something like that, right? Here you go, deploy my application. Here is my application configuration. Now this is done to a specific component of the master called as API server. API server is a component of the cluster or the master or Kubernetes, you would say, which exposes the cluster to external world by using REST APIs. So it exposes REST APIs, and the REST APIs are used to communicate from the external world. right? And also this is used to communicate with other components of your cluster. So the application deploys or application request goes to API server, and then what happens then? If I say that, okay, Nginx port 80, 5 replicas, API server will receive this request, but it does not have its own capabilities to run any pods or any workloads. So there is another component called as scheduler. Okay, now API server will instruct scheduler that, hey, listen here, scheduler, I got a request for running these 5 pods. Take care of it. And then scheduler will say, all right, then I will talk to these nodes and ask them to schedule these pods. Okay, so it will say that, okay, this node run 2 pods, this nodes run 3 pods. All right, so scheduler delegates the pods to be running on each node. Now, how does this communication work? So, right, how scheduler is able to instruct the nodes to run pods? Well, on the machines, there is another tool or another component running, which is called as kubelet.
Thanks for watching. Want to study further? Join our training programs today.